All right, in order to understand your calculus lesson as the derivative as a function, you might need to go back to something we studied in college algebra where we looked at a graph provided or a function given, and we were able to determine where that function was increasing and where that function was decreasing. So now, based on a calculus definition, we're going to talk about that change between increase and decrease is happening at one point or one moment in time. So if we look at this function, first I'll label this function as f of x, just for our purposes, and calling it f of x. I'm going to assume that this goes on forever because there were no endpoints signifying otherwise. So when I read a graph left to right, I first take a look at this, and each value is going to increase as I increase x values. Or in other words, if you were to look at an x value of -2, here's the point on my function, versus maybe -1, here's the point on my function, I can see that my y value has increased. I'm headed up this way. So I would say this whole section here, my function is increasing, and then I sort of stop for a moment here and I turn around, and now I would say my function is decreasing until I get to this nice stopping point right here, where I then again turn around and now I am increasing. And so if I wrote these out as intervals, I would say I'm increasing and decreasing on an interval. And these are going to be x values or input values only. So I'm increasing here in this first section, which I'll highlight green. I'm increasing, coming at an x value from -infinity, because you're coming way out from this way over here, coming out and increasing, whatever that looks like. Okay, so I'm increasing from -infinity to the first x value where I turn around is at x equals 0. And then at x equals 0, we said we turn around and decrease until this x value right here, which is an x value of 4. So I'm decreasing 0 to 4. And then I, again, stop at that x equals 4 and turn around and I increase the rest of the way. And so that would be union from 4 to infinity. And the reason we're going to use parentheses for calculus, we're going to talk about that actual turning point right there as one moment in time, now that we can speak of instantaneous rate of change. So that is going to be where, in other words, our derivative is 0, or where our function is constant. We're not actually at that one moment in time decreasing or increasing. Now, if you had studied increasing and decreasing prior to calculus and you saw brackets on anything, doesn't necessarily mean it's wrong. Their definition of increasing and decreasing is based off of 2 points, and in calculus, ours is going to be based off of 1. Okay, so let's do this one more time. And so, again, hopefully if you can see this, I'm increasing -infinity to 0. That's the first x value where I turn around. Then I'm decreasing 0 to 4. Then I'm increasing from 4 to infinity. Okay, so let's look at one more. Okay, and let's look at this graph as a function. Now again, I'm going to put arrows because there are no points signifying that this graph would end. So it looks like it continues forever on in those directions. And you might be able to tell that there is a vertical asymptote here, which you should have already studied, vertical asymptotes, at x equals 2. So my function will never actually be 2, and we talked about the one-sided limits. As x approaches 2 from the left, I'm headed down here to -infinity, and as x approaches 2 from the right, I'm up here at positive infinity. So let's talk about where this function is increasing and decreasing. Well, if I look from left to right, what I notice from the beginning is that this function is actually decreasing as I look from left to right. And then the only reason I stop is because I physically have to pick up my pencil because I have that point of discontinuity there at x equals 2. And if I go on the other side of 2, I can actually see that I'm still decreasing. At no point in time is this function increasing. So for example, if you look at one particular x value and you increase your x value, your function is never getting larger. It's getting smaller. So the next x value would not have a larger y value than the previous one. Or as you look left to right, you're going down all the time. Now, I would say increasing never. Some will say DNE, like does not exist, or you're just never increasing on this function. But don't get too carried away. Don't say decreasing always, because again, our function does not exist at x equals 2. So I'm going to say I'm decreasing negative infinity to 2, and then union that with 2 to infinity. Because our function does not actually have 2 in its domain, so if it doesn't exist at 2, I can't describe my function at x equals 2. So hopefully that makes sense to you. So this should give you a start. Again, we're going to talk about increasing and decreasing in terms of slopes of tangent lines. So again, if I look at a tangent line at any point on this curve, that slope of that tangent line would be negative. Oops, I missed. But that slope of that tangent line there is negative. And so if we look at the one above, talking about tangent lines again, I can see that all the places where I said it was decreasing here in the middle, all these slopes of these tangent lines are negative, and everywhere I said I was increasing, all of those slopes of tangent lines would have been positive. Hope you found this video helpful just to get you started with your discussion for calculus.